Evaluate the integral of sec 2x dx. Now, how do we evaluate this kind of integral? The sec, this is also a case of a standard integral. If you do it, it is also a case of a standard integral. If you evaluate this, you will get a half ln of sec 2x plus tan 2x plus c. We want to see how is that one coming about. That is a case of a standard integral. A half means the derivative, you divide by the derivative of the inner function, isn't it? So we want to see how ln of sec 2x plus tan 2x is coming about. So before we do that, let us start with a case, because of course we want to evaluate sec 2x dx. So let us use this. What if you want to integrate sec x dx, isn't it? Yeah. When there is no 2, so that we see the standard integral of that nature, isn't it? Now to integrate this, what you do manipulate. If you have sec x, you multiply both numerator and denominator by sec x plus tan x over sec x plus tan x dx. You want to see the reason why you manipulate it in this manner. It is because of standard integration. Are we together? You multiply both numerator and denominator by sec x plus tan x by sec x plus tan x. It's like you are multiplying with 1 because this is same thing, isn't it? Are we together? So from there you see sec x times sec x, you get sec squared x, then plus sec x times tan x, you get sec x tan x, then everything is over sec x plus tan x. Then now this is now what you are integrating. Are you seeing? Are we together? Now we want to use algebraic substitution. Now look at this. If you let u to be sec x plus tan x, look at it. If you let u to be what is, because we said what is in the denominator is what is being substituted in algebraic substitution, isn't it? If you let u to be sec x plus tan x, what do you have? U is sec x plus tan x. So from there we can get du, we can differentiate u with respect to x. Go back to differentiation. When you are differentiating sec x, what were you getting? You are getting sec x tan x plus. When you differentiate tan x, what were you getting? You are getting sec squared in differentiation, isn't it? So it means you differentiated u with respect to x, meaning this is du over dx, you've taken dx on the other side of the equation. Have you seen? Are we together? Now from here you can see the whole of this is the thing you are saying in the numerator, because the numerator is sec squared x plus sec x tan x dx, meaning the whole of this numerator is du. Are you seeing? See the numerator, you have sec x tan x plus sec squared x here. Sec squared base and base dx. Are you seeing the whole of that numerator? It is du. And the denominator you let to be u. Meaning here what you have is du over u. What is du over u? Standard integral ln of u. Isn't it? ln of u. So it means du over u is ln of u. So what is ln of u? U is what? U is sec x plus ln of u. Then that's the arbitrary integration constant. So it means this is a standard integral. Meaning anytime you see you are going to integrate sec x, then you know automatically it's ln of sec x plus tan x. You don't need to do it. It is a standard integral. Are you getting the case? It is a standard integral. You don't do standard integral. Standard integral, you key in the answer direct because it is something which is standard. Is that okay? So it means when now somebody tells you to integrate sec 2x dx, you know that when you let 2x to be t, it's like you are integrating sec t dt, isn't it? So sec t dt, you get ln of sec t plus tan t. Then you put back your t, isn't it? Then you divide everything by the derivative of the inner function, which must be a constant in integration, isn't it? So if you integrate sec 2x, you get ln of sec 2x plus tan 2x. Are you seeing? We are trying to say let 2x to be t. So it is like we are trying to say that you are integrating sec t dt. Are you seeing? So what do you get? You get ln of sec t plus tan t. Then you put back your value of t, which is 2x. Are you getting the scenario? Then the end of integration, you divide by the derivative of the inner function, which must be a constant. The inner function was 2x. Are you seeing? If you differentiate 2x, you get 2. So you must divide by the derivative of the inner function, which must be a constant. Then at the end of integration, you have your arbitrary integration constant. So it means here we have a half ln of sec 2x plus tan 2x plus c. Are we together there? Good. So after that, we now want to see a case. That was example number 9, isn't it? Let us now see a case of example number 10. Look at example number 10.